Now, we have this question. If 2x squared minus kx minus 12 is divisible by x minus 4, find the value of k. Okay? This question is testing your understanding on remainder theorem, which is one of the concepts under polynomials. Okay? And generally speaking, if we have an expression, let's say as simple as 10 divided by 5, or sorry, let's say 10 divided by 3. Let's say we have 10 divided by 3. Okay, of course, you know the answer is going to be 3 whole number 1 over 3. Okay, or let's say we have 15 divided by 4. 15 divided by 4 is going to be 3 whole number, and we have 3 over 4. It can be written as 3 over 4 like this, something like this. Or let's say we have 5 divided by 3. What are we going to have? We have 1 whole number 2 over 3. 1 whole number 2 over 3. Now, the point here is this. The numerator here is our dividend. Is the dividend. Okay? The denominator here, of course, is your divisor. Is your divisor. While the answer here is your quotient. And this 1 that you have here is the remainder. So, generally speaking, it means during division, when you are trying to divide, this expression can be written as, that is, we want to generalize now. If you want to generalize, we could say a dividend divided by a particular divisor will give a quotient added to the remainder divided by the divisor. Now, this is a general rule. This is a general way to visualize division. Take note. Now, another concept that you need to understand when it comes to this aspect of polynomial is the idea that the remainder theorem. Okay, the remainder theorem states that, let's say we have a polynomial p of x. Polynomial p of x, let's say it is divided by a polynomial d of x. If a polynomial p of x is divided by a polynomial d of x, okay, let's say in this case, let's say d of x is x minus a. Okay, the remainder theorem states that if you substitute a into the polynomial p of x, you are going to get the remainder. This is called the remainder theorem. Okay, that is, if p of x is divided by x minus a, right? You're going to get the remainder, and the remainder is going to be p times p of a. Okay, so how did we get a? It's just by equating the dividend to 0. If you equate this dividend to 0, you're going to say that it will imply that x will be equals to a. Okay, so we can use that idea. We can use that idea in getting this problem solved. Since the question wants us to find, the value of k, and we have this expression, we have been told that it's divisible by this. And if it is divisible by this, it implies that x minus 4 is a factor. And if x minus 4 is a factor, it implies that the remainder, when you substitute 4, is going to be 0. That is, there won't be any remainder since it is divisible. Okay, so we could use that idea. We just pick the polynomial p of x. Okay, let's say our polynomial p of x is 2x squared minus kx as given minus 12, right? Then we say x minus 4 equated to 0. Then this implies that we get x to be 4. And if x is 4, what do we do? Just say p of 4 equals to what? 2 into bracket 4 squared minus k times 4 minus 12. And this gives us 2 times 16, that is 32, minus 4k minus 12 will give us the remainder. And since it is perfectly divisible, our remainder is going to be 0, as stated earlier. So from here, if you rearrange, we're going to have 32 minus 12 is equals to 4k. And 32 minus 12 will give us 20. So we have 4k equals to 20. So we can divide both sides by 4 so that we can get k to be 5. So this tells us that the correct answer is going to be option B.